All right, everybody, welcome to Math with Grace. Today we're going to be working through Math 7, Book 705, Lessons 6 through 10. Lesson 6 begins on page 23, and it's titled Listing Prime Factors Using Exponents. The prime factorization of a number often contains many repeated factors. We can use exponents for simpler notation. Each exponent shows how many times that factor is used. So, if you have factored 600 to its prime factors, you have 2 times 2 times 2 times 3 times 5 times 5. Okay? Not that that's the wrong way, because it's correct, but a simpler way to write it, since you have 3 2's, is to write 2 to the third power times 3 times, since you have 2 5's, you write 5 to the second power. That is the easier way to write the exponential factors, the prime factorization, okay? It says here that no exponent means the factor is only used once. That 3 does not have an exponent because it's only there one time. So technically its exponent is a 1, but we don't write the 1 because we don't need to, right? It's implied. All right, so let's take a look at these. When they did prime factorization of 144, they got 2 times 2 times 2 times 2 times 3 times 3. There are 1, 2, 3, 4s. So there's 1, 2, 3, 4 2's. So it's 2 to the fourth. There are 2 3's, so it's 3 squared. For 81, we have 3 times 3 times 3 times 3. There are 1, 2, 3, 4 3's. So it's 3 to the fourth power. All right, okay, let's do some together. For 84, I'm going to try to squeeze them all into this little bit here. For 84, we're going to do the reverse, just like they did up here, okay? The smallest prime that goes into 84, because it's an even number, is 2. So how many 2's are in 84? Well, there are how many 2's in the number 8? There are 4. 8 divided by 2 is 4, right? 4 divided by 2 is 2. So there are 42 2's in 84. Again, 42 is an even number, so 2 goes into that. And how many 2's are in 42? Well, there's 2 in 4, and there's 1 in 2. So there are 21 altogether. Now, 21 is not an even number, so 2 doesn't go into that. So what's our next prime factor? Well, it's going to be 3, right? How many 3's are in 21? There are 7. Because 7 is a prime number, we are done with this prime factorization. So it's 2 times 2 times 3 times 7. Because we have 2 2's, we're going to write it as 2 squared times 3 times 7. Okay, for 260, it is an even number, so 2 goes into an even number. How many times? Well, let's take it one part at a time. There's 1, 2, and 2. How many 2's are in 6? 3. How many 2's are in 0? 0. So there's 132's in 260 altogether, right? 130 is a even number, so 2 goes into that. Now there's 0 2's and 1, so how many 2's are in 13, right? We can't just skip it, so it just becomes a 13. So how many 2's are in 13? There's 6, because that would be 12 worth, right? There's 1 extra. So then how many 2's are in 10? There are 5. All right, if you needed to do that math off to the side, feel free to do that, right? But this is that shortcut method we learned a couple books ago. Now we have a 65. For 65, 2 is not going to go into that. 3 doesn't go into 65. So the next prime factor is 5. And since it ends in a 5, we know that 5 goes into that. And how many 5's are in 65? Well, there's 1 5 in 6. There's going to be 1 extra. And so how many 5's are in 15? There are 3. So there are 13 5's in 65, right? 13 times 5 is 65. 65 divided by 5 is 13, right? We made a little number tree. Now 13, I don't know why I put a box around it, because 13 is a prime number. And so that is at the bottom of our factoring. 2 times 2 times 5 times 3. We're going to rewrite that with exponents where we can. We have 2 2's, so it's going to be 2 squared times 5 times 13. All right, 125 next. Now, most easily, 100, remember when we have a number that ends in a 5 or a 0, we know that 5 is going to go into that. Now, when it has a 0, we also know 2 should go into it, right? So we want to make sure we do our smallest prime first, but in this case, we're going to do the 5. So how many 5s are in 12? There's only 2, right? But that left a remainder of 2, because 2 times 5 is 10. So there's 2 left. Now we have 25. How many 5s are in 25? There are 5. Okay. 25. 5 is also a factor of that. And how many 5s are in 25? There are 5. So for this one, we have 5 times 5 times 5, or 3 5s. So it's 5 to the 3rd power. For number 4, we have 72, right? It's an even number, ends in a 2, so we're going to start with 2. How many 2's are in 7? Well, there are 3. 3 times 2 is 6, so there's going to be 1 extra. How many 2's are in 12? There are 6 of those, so 36. 36 is an even number, so 2 goes into that. How many 2's are in 3? There's only 1 when there's going to be a remainder. How many 2's are in 16? We have 8, so it's 18 altogether. 18 again is an even number, so we're going to put a 2. How many 2's are in 18? Well, there's 9 of those, right? 2 does not go into 9. 9 is not an even number, right? But 3 does. And how many 3's are in 9? There are 3 of them. Okay. 3 is a prime number, so we're done with our factoring. We have 2 times 2 times 2 times 3 times 3. So we have 3 2's. So we have 2 to the 3rd power times 3 squared, because we have 2 3's. Okay, you getting the hang of it? All right, one more. 99. Now, when there is a number less than 100, that is just a repeated digit, 66, 77, 88, 99, 22, 44, right? We know that 11 goes into that. Now, we're doing it a little bit out of order because 11 is not the smallest prime, but it's the most obvious. So we're going to pull that out. And how many 11's are in 99? There are 9, right? That's how we get 9 times 11 is 99, right? Now, we just did the 9 factoring right here, right? Because 3 goes into 9 3 times. So our factors are, because we want to write them in order from smallest to biggest, 3 times 3 times 11. Well, we have 2 3's, so it's going to be 3 squared times 11. Okay, so remember, the exponent represents how many of those things are being multiplied by each other. So when we have 5 to the 3rd, it's 5 times 5 times 5. When we have 3 squared, it's 3 times 3. Okay? So that's all we're doing. The factorization we've been doing this whole time, we're getting super good at it. We are just writing our answers in a little bit more concise form. And that's by using the exponents. All right, good job. We're going to turn the page now, and there is one more little bit we're going to talk about. Now here at the top of page 24, it says memorizing the powers of smaller prime numbers. Now, you know how I feel about memorizing, okay? Here's a nice little chart. Maybe fold the corner of this page over so you can reference it. I would not sit down and actually memorize these things, but as we move forward, you're going to use them enough that eventually you probably will have them memorized without actually spending your time memorizing them. Does that make sense? All right, we use these a lot. They're used a lot. Through that use, you will end up having some of them memorized. So you don't necessarily need to spend the time sitting here memorizing them. Does that make sense? I think it makes sense. Okay, let's just look at them, okay? We're just going to fill this out. And when you get to this part of the work, just come back and double check. Maybe say, oh, I think I know this one. Write it down and then double check, okay? Use your book to make sure you're doing things correctly. All right, so 2 to the 5th power is 32. Okay, it's 2 times 2 times 2 times 2 times 2. 2 to the 3rd power, this one you're going to use a lot, and you will probably eventually memorize it, is 8. 8 times 8 times 8, right? Or 8 times 8 times 8, sorry. 2 times 2 times 2. All right, 2 to the 4th power, 16. And 2 to the 6th power, that one you don't use as often, but we will use it sometimes, is 4. Okay? And I feel like what they're trying to do here is if you were factoring, let's say, you were factoring, what is it, 128, right? If you play Minecraft, you probably already know what that is, right? But if you're factoring this and you're like, oh, a 2 goes into that 64 times, and then they want you to just to recognize, oh, well, 64 is 2 to the 5th. So altogether, I have, the answer is 2 to the 6th power, right? Because we have to add this extra 2 back into here. I think that's what they want you to recognize. If you don't recognize it for a while, that's okay, right? You can just continue to do the math like we've taught, and you'll get there, all right? 3 to the 3rd power is 27. 3 times 3 times 3. 7 squared is 49. 5 to the 3rd power, we just did that one on the page before, is 125. And 11 squared is 121. And they have a 13 squared on here. Not sure why they chose 11 and 13 to square and not 12 or 14 or any of those. But hey, we don't typically deal with 11s or 13s or anything like that to the 3rd power and to the 4th power. That's really not. Probably because 11 and 13 are primes. I guess that makes sense. Duh. Okay, these are all prime number factors. Prime numbers to a power. But a lot of squaring of things you will use enough that you will eventually probably have them memorized. But here's a nice little chart. Just use it for now. Okay? Don't sit here and work on that. Silly. All right. I've rambled on too long. Okay, go ahead and finish the We Remember and meet me back here when you're ready for lesson 7. Lesson 7 begins on page 28, and it's called Reflex Angles. So it says, we have learned about acute angles that measure between 0 and 90 degrees, right angles that measure exactly 90 degrees. Okay, here's our acute, here's our right. Obtuse angles that measure between 90 degrees and 180. And then straight angles measure exactly 180 degrees, and they look like a straight line. But a reflex angle is any angle larger than 180 but smaller than 360. If we keep bending this outer edge around, okay, we go farther than that straight line. And then we have these kind of strange looking angles. They're called reflex angles, okay? So let's answer some questions here. A reflex angle measures between, right here, larger than 180 degrees and smaller than 360 degrees. Okay, so now they want us to label each angle. Acute, right, obtuse, straight, or reflex. These are the words that they want you to use for your answer. So this one goes all around. Remember, if this was a straight line, we've gone past it, so this is a reflex angle. But what about this one? This one opens up but doesn't quite make it to a straight line, just like this one here, right? This is obtuse. Here we have an angle that opens up but doesn't quite hit the 90 degree, right? The straight up and down, so it's an acute angle. All right, let's head up here to the top of page 29. I'll try to keep everything on the page. Here we have a straight line, right? Straight lines are straight angles. So straight Okay, the words are right here. Make sure you're spelling them correctly. Here's where we're starting. When we're doing these, maybe I didn't go into it too clear. Where this swoop touches the line, that's the beginning point, and the arrow is at the ending point. This has crossed a straight angle and gone beyond it, so it is a reflex. And here's where we start and we're stopping. And look at our little doghouse here. Our little marker tells me that this is a right angle at 90 degrees. All right, so just different types of angles. Go ahead and review what they are called. Finish the We Remember and meet me back here when you're ready for Lesson 8. Lesson 8 begins on page 33 and it's titled Formula for the Volume of a Cylinder. All right. New formula. So the formula for finding the volume of a cylinder is that the volume is equal to big B times H. Remember, the big B in the formula represents the area of the base. And in this case, the base is a circle. The height may be a vertical or horizontal, but it's always the distance between the two circles. Remember, a cylinder is a circle and an identical circle separated by some height. Okay, even when it's on its side, here's a circle and a circle separated by this height. So the area of a circle, remember, is pi r squared. So instead of writing the volume equals big B times H, which is very generic, we could write the volume equals pi r squared times H, because the area, our base, our big B, is a circle. And then in doing that, we can just substitute in the information we were given. Pi, we are using 3.14. The radius squared, remember in the lesson a few minutes ago, we learned, or I guess maybe for you a couple days ago, we learned that squared tells me I need 2 of them. So my radius is a 5 and I need 2 of them. So 5 times 5 times the height, which is 8. And then we just in our calculator, and we get our answer, is the volume equals 628. But we're talking about volumes, so it's unit of measure, in this case meters cubed. Volume is always a cubed measurement, and that says here, remember, the volume is given in cubic units, so it is 628 meters cubed. All right, let's turn the page and do some of these together. All right, on page 34, they've only given us 2 to work on, but we're pros, so we got this. And our volume, remember, is going to equal, because it's a cylinder, pi r squared times H. I like to write the formula right here at the top, so as I'm working, I can see it, right? So problem number 1A, my volume is going to be equal to, and they don't give us a specific that they want us to use for pi, but I'm just going to use the normal 3.14. So 3.14 times my radius squared. What is my radius? Well, it's 10. And how many of them do I need? I need 2. So 10 times 10 times the height, which in this case is 12. Okay, so 3.14 times 10 times 10 times 12. Grabbing my old trusty Casio here, I have 3.14 times 10 times 10 times 12, and I hit equals, and I get 3,768 centimeters cubed. My unit of measure cubed. Okay? All right, let's take a look at the next one. For this one, I have that the volume is going to equal pi, which is 3.14, times my radius squared. What's my radius? My radius is 2. How many 2's do I need? I need 2 of them. And times the height of 10. So I have 3.14 times 2 times 2 times 10 equals 125.6 meters cubed. Okay, do not forget your unit of measure. If they supply a unit of measure, it should be in your answer. Unit of measures cubed. So using our formula, we substitute in what we know. Pi, 3.14. Our radius, in this case, was a 2. How many do I need? I need 2 2's because it's the radius squared. So 2 times 2 times the height, which in this case was 10. Then we just multiply them all together. 3.14 times 2 times 2 times 10. Do not forget any of the pieces. Double check your work. And then we top it off with our unit of measure cubed. Okay? All right, that's it for lesson 8. Go ahead and finish the We Remember and meet me back here when you're ready for lesson 9. All right, lesson 9 begins on page 38, and it is titled Building Line Graphs. It says here, line graphs show a change in a particular value. The number scale for a line graph must go up the left-hand side of the graph. That is the case because for each of these that we label along the bottom could use the same exact number, or the same number could be used multiple times. So we like to have our numbers go up the left-hand side. But they don't need to start at 0, okay? We want to look at our data. And in this case, we don't actually have the data for this graph. They've just graphed it, right? But we want to look at our data and say, okay, what is the smallest value? And in this case, it's right here. It's like a 78 or 79. And we want to start just under that. So technically, this line graph honestly could have started at 70, would have been fine. And then we want to look at our largest piece of data, which in this case is this 95. And go a little bit higher than that. So they went to 100. So technically this graph could have been just from the 70 to 100. Would have been more because honestly, right, all this is kind of just wasted space, right? So that's kind of how we judge where our number scale should begin and end. And then we just make an appropriate amount of space in between each of our points and we graph it, right? So it says we estimate the correct position of a point as closely as possible, right? Like I've said before, most of these graphs are reliable-ish, but there is definitely rounding, okay? Depending on the data being graphed, the line may be straight, curved, or broken. Here is a curved line graph. Here is a straight line graph. This is a broken line graph. Right? It goes up, down, up, down, up, down, up, down, up, down, 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 right? Whatever, okay? So that's what we have here. Let's take a look at the top of page 39 to see what's the what. Okay, using the model on page 38, complete the line graph of the information given. It says Mabel is diabetic. Marlene helps her take her blood sugar count twice daily and records the readings. The readings for last week are shown on this table. Now they've already started numbering it for us, so we're just going to continue the numbering. We're going to skip a line and then write a 10. So we have an 80, 90, skip a line, 100. 100, we're going to skip a line and write another 10. So 110. Skip a line and write another 10. 120. Skip a line and write another 10. 130. All right? And then we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So now we need to plot our points. Okay? Complete the line graph given. So Sunday morning, we have an AM and a PM line, so be careful how you're graphing, right? Sunday morning, it was at 90. So here's Sunday AM, we were at 90. And Sunday PM, we were at 125. So here is 125. Okay. Monday morning, we were at 100. So here's my Monday AM. I'm going to put a point at the 100. And Monday evening, we were at 95. So Monday PM, we were at 95. Monday seems like it was a pretty good day. Tuesday morning, we were at 90. So here's my Tuesday AM. I'm going to go 90. And Tuesday evening, though, we were at 130. I don't really know much about blood sugar, but that seems like a lot. Okay. Wednesday AM, we were at 95. So that's right here. And Wednesday evening, we were at 85. So that's down here. It's our lowest recording thus far. Thursday morning, we were at 95. So again, with the Thursday morning. And Thursday evening, we were at 95. All right, Thursday, you're hitting it Thursday. All right, Friday morning, we were at 100. So Friday a.m., we're at 100. Friday evening, we were at 80. You know, you need to drink some more water, Mabel. All right, down here, and maybe eat some. Saturday morning, we are at 85. Typically, you don't want your lowest point to be at the bottom or your highest point to be at the top, typically, all right? But let's just keep going. Saturday, 85 in the morning, 95 at the evening. So right about here. Now, I would probably draw my line connecting the AMs to the AMs and the PMs to the PMs, but I don't think that's what they're looking for here. So we're going to just start and work our way across. So here's to there, she spiked. From here to this, so PM to AM, AM to PM, PM to AM, AM to PM, spike right there, PM to AM, AM to PM, PM to AM, that one's easy enough, AM to PM, PM to AM, AM to PM, PM to AM, AM to PM. Okay. Mabel had a rough ride this week. All right, I'm sure that's tiring for your body. So it says here, question number 2, on which day and time was Grandma's blood sugar count the highest? Oh, so she's a grandma, Mabel. All right, Grandma's blood sugar count the highest. Which day? So what is the highest point? Is right here, right? And it was Tuesday. Give the average blood sugar reading to the nearest whole number. All right, now I find this question to be slightly absurd because we haven't actually, in any of our lessons thus far, talked about averaging things. And so maybe you know how to find the average and maybe you don't because we're learning, right? So maybe you don't know how to find the average. So I'm not actually going to expect you to calculate this. I would never have asked that question. But looking at the chart, because they want it to the nearest whole number, right? We're going to estimate. Looking at the chart, we're going to estimate. Now remember, an average is about the middle, right? We're looking for about the middle. And the best way to find that is to think, well, where is the point where most of the numbers fall? Okay. And I would say that most of the numbers fall in between here, right? In between this 90 and 100 space, we're just going to use the line graph for what it is. If you know how to find the average to the exact number, you go ahead and do that. If you don't feel bad. We've not even talked about it. I'm sure it's coming up. I'm not going to teach it now today because that's a whole nother lesson, okay? But looking at the graph, we're going to see that a lot, not all of them obviously, but a lot of them fall between these two spaces. And a lot of them fall kind of just right in the middle. So an estimate that I would give is 95. Now I actually did the math and it turns out to be like 97-ish. But I know how to find the average of something because I've been taught that. And so I don't have time. We're not going to learn a whole nother lesson here on how to find the average of numbers. But looking at our line graph, because that's what they're for, I would say it's approximately 95, whatever the unit is for this 95 blood sugars. I don't know. Like I said, I don't really know that much about blood sugar. So I don't know what the unit of measure is for that. But it's about 95. That's a good estimate based on this line chart. Okay? So if you don't know how to average, don't worry about it. We will get to it eventually. But that's a whole nother lesson. But looking at our graph, I would say that's a fair answer. Okay. That's it about line graphs. That's it for lesson 9. As always, finish the We Remember, and then you can take your quiz 2, which is in the back of the book. If there's a question, let me know. All right. Otherwise, Until next time.